Hello everyone, how are you? My name is Mariam, and I'll be today sharing with you about this topic, containerization versus virtual machine security and efficiency trade-off. And my name is Mariam Hamatto. So first of all, let's tell you that we're gonna talk about like some introductions about the topic. So so here, let's tell you about the problem first. Forgot topic. So here, imagine that you, for example, have a world where machines can decipher language, recognize faces, diagnose diseases, and even make predictions without explicit programming. So that's a great thing, right? Yani that's something very good to imagine. So we will embark on a journey through the ever-evolving landscape of artificial intelligence and machine learning. We'll explore the core of concepts and the transformative potential of these technologies. So we're talking about an example about virtualization. We want to talk about artificial intelligence and machine learning, how they come together. Yes. So, and also we can talk about something else. So first of all, what is virtualization? And here it's focusing very good about the artificial intelligence, but I want you to know about the meaning of this. So our key concepts in this course is going to be about Docker efficiency, kernel, virtual machine security, and cloud computing isolation, hypervising and stuff. So here we're going to tell you about the first thing that we're talking about the virtualization, right? So the virtualization in the cloud computing, and we're doing a comparison between virtual machines and containers. This is our topic. So virtualization is the core technology, it's the core thing in the cloud computing because it's very important that it has multiple work like on the same physical machine. For example, imagine this problem that we have some applications that we want to upload on our device, for example, any type of device that we have, and this device is this application doesn't work on your laptop and you really need it, like, okay. Yes, so we need something called virtualizations, that we just have like to log in, or we are the users in this device, and we just like it's gonna work on different devices. So this is what it helps, that it's efficient, it's fast, it's isolation between applications, and it's also it can work on the operating system, and its deployment in multiple workloads, as we're saying. And what's nice that instead of buying another machine to work on it and to operate another operating system just to go and do what the work on it or open our application, we just like it reduce the payments, like instead of buying, like it reduce hardware costs, and it's also support distributed systems like we mentioned before. So we just know about that. Virtualization has two important things, which are virtual machines and containers. Virtual machines focuses more on the something called hypervisor, if you know about it, and also other things, right? So here we want to tell you about we want to tell you about this topic here. So let's go and talk about containers, since we already spoke about the virtualizations. So containers, here it's operating system level virtualizations, and also it's lightweight. So here what we gain of containers, that it's a lightweight and share host OS kernel. Yeah, there's one important thing, that virtual machines or containers, they both depend on kernel. Kernel is the head of any device that really organizes everything. So what's advantages about containers? Containers is thing like it's like a bag that carries stuff, that it's lightweight, and it's also faster and for scalability. So these are main stuff and main differences about it. So here we have some real world applications. For example, in healthcare professionals, it's very useful in educational and smart grid system, AI, natural language processing. All these are important types for the stuff, right? So, so I want to tell you more about virtual machines right now because it's a really important thing that virtual machines have it runs on an operating system. You know, every device has its own operating system, so it's just can be inside like it's fully on one operating system. There's something that it uses, it's called a hypervisor. Hypervisor is very important thing because it really shows so important things. So let me show you an example about hypervisor. One moment, please. Here, let's share with you something important from here. Yeah. So here, if you see here, we're gonna find an example of the hypervisor, like what? VMware. So this is how it looks like. Here it's written announcing VMware carbonators, and also you can add a platform, cloud infrastructures, security. So our topic is also talking about security and efficiency, applications and stuff. So this is very important. So what we want to say about sincere saying secure accelerate your journey to zero trust and protect from ransomware means it does protection. That means it's strong kernel level isolation, and it has suitable sensitive workload and secure boot and stuff. What's the negatives of this thing is that it's it has something. I want to say the memory or the storage, RAM. It's high overhead on the RAM, and its performance is very popular. That is from 10 to 20% performance loss compared to any native executions and codes and stuff. So this is when we talk about virtual machines. Let's come now and talk about containers. Okay. So here, okay, let's come back over here. One moment. One moment, please. I want to show you about something very important. Okay, guys. Let's show you about the containers. Mhm. So, guys, I see over here that was our report, introduction, background, and stuff. As we go, container security. So here it's talk about container. So container, it has a setting that it's an operating system kernel features. Yes, that it relies on namespace and control groups for isolation, not like virtual machines. Yes, all containers share same kernel. Yeah. So this is something that uses isolate processes, also overlay FS or use layered images and stuff. Yeah, and there's a feature that it starts in milliseconds. Yani this is very, very fast. And it's very light, high scalability and stuff. What's its weakness or its bad points? So here, as we know, it's very good and fast and it works on the Linux. It uses Linux very much. Weakness that its kernel is shared, all the same kernel, the same stuff, which is not very good. Let's take a look. So that's the thing. So let's compare between them on the security. For example, what's the difference between virtual machine and the container. So virtual machine has its own kernel, okay, and it's best for untrusted workloads. That's so good. And as we mentioned before, applications in healthcare with the people, finance and governments, it's very, very good to use a virtual machine because it's private, they can share the stuff. But if you're talking about a container, it's not good for this, but it's share host greater attack surface, so it can be like attacked. It can be attacked very soon, as is mentioned over here in front of you. Although it uses namespace and C control, it has a risk container escape. Here, as it mentions, CVE 2019 5736 during exposed learning how attackers could overwrite binaries and gain roots. Yes, this is the root is in front of us. Need extra hardening app amor sil nox. Yes, and it needs more as is here. So in the security, we learned that virtual machine is much stronger for isolation. In container, it has a container like sufficient security, and it just very only in very trusted environment you can share it. Yeah, and it has some threatening stuff, right? And we can compare now between the efficiency our point of view that in containers it has higher efficiency than virtual machines, as it's written here. Look, how is that it's near naive performance, like it's very popular. It's 89% for performance. It's very fast, as we mentioned, because it's all in the same kernel, and high density. Yes, density deployment sense it's like that, and scaling apps CI/CD. Okay, operating configuration. I'm on the virtual machines. It has lower efficiency. Yes, it's full operating system per virtual machine. So this is plus, but the storage, it's higher RAM. It has more storage because it has its own like own place. Performance penalty 10 to 20%. Here, as it says over here, density and kernel sharing and comparison, blah blah blah, trade-off between isolation and efficiency. What we want to say that containers win in speed, it's very fast, and in cost, scalability, and performance. Okay, guys, there's something called hybrid model, and talk about it. That virtual machines is for very sensitive data, as we mentioned, banks, governments, healthcare, the biggest example. Yes, virtual machine for security, sensitive workloads, containers. It's for like microservices. Let's think about it in hybrid. Actually, look at this. It also summarizes what we were talking about, like we mentioned before, between them. Yes. So here it says about performance overhead contains 5%, but the this one is 10-20%. Best choice for systems. It balances security and what efficiency. Hybrid approaches. We see defense in depth widely. Okay. And that's it. Thank you really for watching. I hope you really learned very much and stuff, and I hope I really explained for you the general idea and everything. Thank you so much, guys.